Hi everyone, my name is Prasansa Gimire, and today we're going to talk about a topic called cystic fibrosis. I want all of you to imagine having to breathe through a straw for the rest of your life. That's what breathing is like for someone with cystic fibrosis. So let's start. Cystic fibrosis is hereditary genetic disorder that leads to the production of thick, sticky mucus, primarily affecting the lungs and digestive system. It's a genetic disease that mostly affects the lungs and digestive system. It causes thick, sticky mucus to build up, making it hard to breathe and digest food. Oftentimes, I get a mucus as well. Like oftentimes, I used to get these before, and when I was back in Nepal. So, but it's good now. So let's move on to the topic. And this is the symptoms listed over here. So this is a chronic cough and wheezing, frequent lung infection, salty tasting skin, poor growth despite a good appetite, and so on. So let's move on to the next one. We have a table of contents. So we have a gene involved, common mutation, and type of mutation. So CFTR, cystic fibrosis transmembrane conductance regulatory gene. This gene, so the most prevalent mutation is F508, accounting for approximately 70% of CF cases. We have a type of mutation as well. You can see that how bacterial infection and thick mucus blocks the airways. Let's move on. Inheritance pattern. So inheritance pattern is inherited in an autosomal recessive pattern. Like this means a child must get two copies of the faculty gene, one from each parent, one from father and one from mother, to have the disease. The gene involved is called CFTR gene. It's right over here, CFTR gene. So let's move on to the third one. Scientific and social relevance. CF is one of the most common genetic disease, like mostly in the European DSCAN, and I think it helps scientists understand how genes control cells function. It is written over here as well. CF research has led to advancement in gene therapy as well as personalized medicine. Understanding this insights help like into making medicine. We also have like a social implication, like early diagnosis and treatment have significantly improved life expectancy for CS patients. New treatments like gene therapy gives hope for a cure. CF also raises awareness about career testing, early diagnosis, it's written over here, the cost of long-term care. Let's move on. Cellular impact. CFTR protein function. Normally, CFTR regulates chloride transport across cell membranes, maintaining the balance of salt and water. CFTR protein controls the flow of salt and water in and out of the cells. When it doesn't work, water stays inside the cells and mucus becomes thick. It is written over here as well. We have effect of mutation as well. F508 mutation causes the CFTR protein to misfold, preventing from reaching the cell surface. This disruption leads to impaired chloride transport. So we have a consequences as well. Mucus becomes thick and sticky due to reduced water content. This mucus obstructs airways, blocks in the lungs, and ducts in the pancreas, leading to digestive issues. Thick mucus blocks airways in the lungs and causes infection as well. Diagnosis and treatment. We have two types of diagnosis and treatment. The first one is sweat test. People with CF have very salty sweat. Measure the amount of chloride in sweat. Elevated levels are indicative of CF. The second one is genetic testing. Identifies mutation in the CFTR gene. We also have another kind of treatments. Let's dive into it. Meditation. Meditation, Medication to thin mucus. Drugs like Trikafta help correct the CFTR protein function. We have antibiotics to prevent infection as well, and we have nutritional support, enzymes, supplements, and high-calorie diets to aid digestion. Airway clearance, technique and devices to help clear mucus from the lungs. Lung transplant in some of the cases. Chest psychotherapy to lose some mucus, or maybe use the drugs to help faculty protein work. Let's move on to another one. So we have a conclusion. Cystic fibrosis is a serious genetic disease that affects how cells move, salt and water. A small change in one gene can cause big problems in the lungs, digestive system, and other parts of the body. Thanks to science and new treatments, people with CF are living longer and healthier lives nowadays. I think mostly understanding CF shows how important our genes are and how even one mutation can change the way our bodies and our cells works. We have to understand how genetic affects our health, and how understanding this can help make more medicine in the future. And thank you, and do let me know if you have any questions. Thank you so much.